I'll show you some more problems regarding speed chart. Okay. Have you collected the speed chart or not? Please download it from the Google. Okay. See, this is the speed chart. The complete speed chart, black magic design. Okay. So here you put your roll number as well as the batch. Now let me show you a problem regarding this. Let's say, let me find a problem. Let's say ZL, that means the load impedance. Load impedance is what? 50 plus J100. Okay. Ohm. That is our load impedance. And say characteristics impedance is 50 ohm, right? Characteristic impedance is 50 ohm. And load impedance is this one. Now, now I need to find out the normalized value of ZL. What is the normalized value? 1 plus J of 2. How I get this? ZL divided by Z0. That is ZL divided by Z0. If you divide that ZL by Z0, then you'll get 50 by 50 is 1, 100 by 50 is equal to 2. That means 1 plus J of 2. That is our normalized value. Now I have to put this one into the speed chart. How to put it? Okay. Okay. How to put this one? See very carefully. Okay. Let me show you. One means this circle. One means this circle. Since it is positive, that means it will be in upper part. So I just this circle. Sorry. Detroit. So we are concerning about this. Okay. And J2. Here is the 2. So this is 2. So that is the point, ZL prime. ZL prime. 1 plus J2. Okay. Now I put the load impedance here. Now connect it to, now connect the center. Okay. And this distance is rho. And if you enhance it up to the outer circle, then you get the angle of reflection coefficient. Angle of reflection coefficient somewhere here. Angle of reflection coefficient is 1. this circle, maybe around 45, roughly around 45 degrees. And what is the value of this rho? Take this distance and put this under the VSWR, under the scale, in the lower scale. You have to put this value here. Put this scale here. You have to put this scale here, and you get the value. You can determine the value. Now let me show you another thing.
السلام عليكم. Sir.
Yes, I will open another slide. Example, so that you can find the examples. More examples. Okay, this is another slide. I have opened it to show you the examples here. Okay, so see, when adding elements in series, use Z chart. That means the impedance chart. When adding elements in parallel, use Y chart. That means the admittance chart. So there are two types of Smith charts. One is impedance chart, another one is admittance chart. So which one do you use? Generally, we do use the impedance chart, but sometimes we may regret to use the admittance chart. But it depends on our requirements. Okay, see. Further examples. Now, from the beginning, see, Z0 is 50, ZL is 100. Z0 is 50, ZL is 100 plus J50. So, what would be the value? Value would be 2 plus 1, J1. 2 plus J1. 2 plus J1. 2 plus J1, that is your normalized value of the load. 2 plus J1, that is your normalized value of the load. So what is the value? So not 2. Maybe that is your point, intersection point. That is your intersection point. 2 plus J1. Now increase this, and you will get the value t is equal to 0. T is equal to 0. T is equal to 0 or half of lambda g. Lambda g wavelength, guided wavelength. Half of lambda g, that is half of lambda g, 0.5. 0.5. Now, what would be the value at the distance 3/8 lambda g, or quarter wavelength? That is the quarter wavelength. That is 3/8. These are the points where it intersects the VSWR chart. So from here, if you move up to this, then you'll get this value and the quarter wavelength. If you move 3/8, then you'll get this one, and here you will get the half. So these are the values. So the value at lambda g by 4.4 minus j.2, this point. So if you multiply it, then you get this one, multiplied by 50. Multiplied by 50, then you get. Okay. Now see this point, what is the value of lambda g? And this point, what is the value of lambda g? This point, this point, this point, this point. At 3/8 lambda g, this is 0.5 plus 0.5. This is 0.5 plus 0.5. Half lambda, 2 plus 1, half lambda this one. Okay, and another example. 50 ohm. Admittance. Okay, I'm just skipping the admittance part. Okay. Use relatively loaded section of transmission line. Non-absorbing load, that is RL is equal to 0. Most common to use open or short loop. You can use open or short loop. XL infinity, that is the open load. XL equals 0, that is the short loop. This is point of short circuit, that this is point of open circuit. Remember, in the impedance chart, this part, that is the most rightmost point on the chart, is called the point of open circuit, that is POC. And rightmost part of the chart, the point of the chart is known as the point of short circuit, that is the PSC. Okay, remember these two things, PSC and the POC. POC means point of open circuit, PSC means point of short circuit. Okay, and see, this point open circuit, this point short circuit. These are the value if you put. See, for the impedance, that is reactance. For the admittance, that is susceptance. Okay, for the admittance, it is susceptance, and for the impedance, this is called the reactance. Okay, susceptance, reactance. Okay. Use a short-circuited section of airfield TEM between transmission line to create an impedance of at f equal to 10 gigahertz. Okay, so that is your input impedance. Input impedance is given as minus 25, J25. Frequency is 10 gigahertz. Transmission line is 50 ohm. Short-circuited section of their field TM transverse electromagnetic. TM means transverse electromagnetic. Now see, that is our impedance chart. Input impedance is minus J of half. So we have to put this one since it is short circuit. So we have to put this value. This circle will be there, and air is 0.426 minus 0 g lambda g is equal to, that is your point. Okay, minus half point. This is your half point. This one, and this distance is your length, which is 1.28 centimeter. 1.28 centimeter. And lambda dot c by f, which is equal to 3 centimeter. Wavelength. That's it. That is your wavelength. Admittance, I'm not considering the admittance. Okay, another these are the another things in where you have to match the circuit. Okay, so I will come to this point later. For matching method, we will come to later. Now let's move on some other maths. Okay, move on to the transmission line problems. Just skip the first one. This is not that is not prepared. From the second one, a pitch of ideal micro transmission line of characteristics impedance 50 ohm is terminated with a load impedance of 100 plus J50 ohm. Calculate reflection coefficient, transmission coefficient, VSW and interval. See, what is the requirement? A pitch of ideal micro transmission line of characteristic impedance 50 ohm is terminated with a load impedance of 100 plus J50 ohm. Calculate reflection coefficient, transmission coefficient, VSW and intervals. So you have to calculate these things by using the given informations. Okay, first of all, let us see which informations are given here. Z0, that means that characteristics impedance, which is 50 ohm, is given. ZL, that is the load impedance, which is 100 plus J50 ohm, are also given. Now, reflection coefficient. What is the reflection coefficient? The reflection coefficient is ZL minus Z0 divided by ZL plus Z0. ZL minus Z0 divided by ZL plus Z0. So ZL is 100 plus J50 minus 50. divided by ZL plus Z0, that means 100 plus 50 plus 50. So that is 0.447 angle of 26.5 degree. 0.47 angle of 27 degree. So what is the transmission coefficient? 2ZL divided by ZL plus Z0. 2ZL divided by ZL plus Z0. 1.41. So it comes like that. And what is the value of VSWR? 1 plus magnitude of rho divided by 1 minus the magnitude of rho. So look at here. What is the magnitude of rho? 0.447. 0.447. So 1 plus 0.447. 1 minus 0.447. Which is 2.62. So VSWR is 2.62. And return loss 20 log then 0.447 minus 6.99 dB. Minus 6.99 dB. Okay. So that's how we can calculate this one. So what we have found here, return loss, RL, reflection coefficient, and transmission coefficient, and the VSWR. So these things have been found here. Okay, using this problem. And the second one, a 50-ohm lossless transmission line of 5 cm terminated with a short circuit. Now the load is short circuit. That means ZL is 0. The line is fed with 3 gears as well as signal. Relative permittivity of the dielectric material of the transmission line is 2.2. Now they have said that the 3 gears sinusoidal signal has been fed, and the relative permittivity of the dielectric material transmission line is 2.2. That means the epsilon R is 2.2. Now we have to find out the input impedance between the ZE. Also find the magnitude of the reflection coefficient, the rho, VSWR, and the return loss of the shorted line. So we have to find these things. Okay. Find the input impedance of the line. Also find the magnitude of the reflection coefficient and the return loss of the shorted line. Now, Z0 is 50 ohm, F into 3 gears, L into 5 cm, and F1 is 2.2.
Which one, sir?
See, according to this one, so you have to draw the figure to understand these things clearly. Okay, so first of all, this is the figure. Okay, that is load. Load is short, right? Since it is shorted, English. Okay. Now that is this is the line. So what they have said that F is 3 gears. F is 3 giga. Right. F is 3 gigahertz. Relative permittivity, that means the epsilon R is 2.2. And what they have said, and 50 ohm, that is not this line impedance or the characteristic impedance, it is 50 ohm. Okay. So epsilon R, that is 2.2, that not 50 ohm. Now find the input impedance, that is the ZE of the line. Also find the magnitude of the reflection coefficient, VSWR, and the return loss of the shorted line. So you have to calculate these things. So let me show you. Now see, since the line is short circuited, that means ZL is equal to 0. So what would be the input impedance? Say not 10 meter. So here V is equal to C by square root of epsilon R. So find out the velocity, that is 2.02 times 10 centimeter per second. Velocity, one thing is per second would be there. and lambda is equal to b by f. So put this value lambda. So beta L is equal to 2 by lambda into L. So put this one, then you will get the 266.9 degree. And what is the then you put these values here, then you will get ZE is equal to ZZ dot and beta, the 947 angle of 90 degree. So reflection coefficient is 0 minus Z naught divided by ZL plus Z naught is equal to 0 minus 50 by 0 plus 50 is equal to 1. Okay, so VSWR is equal to 1 plus magnitude of rho divided by 1 minus magnitude of rho. So it is infinity. Remember one thing, the range of the VSWR is 1 to infinity. So return loss value 20 log 10 stability. Okay. So similarly, you can do the calculate number 4 and 5, 6, 7, 8. Those are home tasks. Let me show you the number 4. Okay. A pitch of microtransmission line of length 5 centimeter and a 50 ohm characteristic impedance has terminating load impedance of 25 plus J25 75 ohm at its end and is fed with a linear signal source at its input. The dielectric constant of the material is 1.8. What is the value if the input impedance at the source plane? What is the magnitude and angular reflection coefficient at the load end? What is the value of this at this point? What are the values of maximum and minimum impedances? See, many things are given, are required also. So first of all, let us find which things are given. Z0, 50 ohm, ZL, this, and F and epsilon R. Now, what is the value of input impedance? This thing. Now, velocity, as usual, lambda, beta L. Then calculate the cos beta L as well as sin beta L, input impedance. And rho, VSWR, Z max, and Z min. See, all are the game of formula. You have to put the values into the formulas, then you'll get the result. And remember, I'll give you in the questions paper previously. I gave that provided the formulas in the question paper, but since now it is assignment based, so you can open the book and you can find out the formulas here. Okay, that is open book, no problem. Okay, assignment is open book, you know well, right? We give you the certain time and you submit the assignment. That means the open book exam. Okay. That's how you have to solve these problems. And these four, these are your home tasks. You see this, and I am uploading all your records today. Okay, and you check this out, these problems at your home, then you'll show me in the next class.
Okay, sir.
Okay, from the 5, 6, 7, 8. Moreover, you need to give a quiz. When I'll take next Tuesday.
Okay, sir.
And when will your need exam? What is the date?
We don't know, sir.
You You don't know, not decided yet. Okay, I'll take the news today. Whatever. In the next Tuesday, okay. In the next Tuesday, that is the 12th. 12,
Yes, yes.
you will have a quiz and syllabus. What is the syllabus? First chapter. Not math, only quiz. That means MCQ, right?
Okay, sir.
You know well how we take the quiz. Only MCQ.
Yes, we know.
Yeah.
Only MCQ will be there. No assignment based quiz. MCQ.
Okay, sir. For 12.
12.
Okay, sir.
Remember, 12th of October, you will have the first quiz.
Okay, sir.
Okay. Or if you want, you can give it on the other day at night. No problem.
Months of exam. Sir, 12 October is exam day.
When exam? 20?
Midterm exam. 12 October.
12 October exam date.
Yeah.
Okay, then you can give it on the next Saturday. Do you have any class Saturday?
No, sir. Off days. Off day, not class day.
Your off day.
Yes.
Okay, then I can take your class Saturday morning.
Okay.
Okay, then that means the quiz. Okay, so Saturday 10:30 a.m. we'll take the quiz. Okay.
Okay, sir.
I think that's better. In that case, today I am uploading all.
Sir. Hello, sir.
Yes.
Sir, change that time, sir. Maybe morning, maybe it's good, sir. 9 a.m. That's good time, sir.
First exam. 12.
No, what time will be quiz? Thursday.
Saturday is better, or Thursday. Which one? I think Thursday is not possible.
Thursday, sir. Thursday. It's not Saturday.
Thursday.
Thursday. I need to get Thursday, sir. Thursday.
Thursday means day after
Yeah.
tomorrow.
Yeah, yes, sir.
Next Thursday, 7th.
No.
Thursday.
لا،
والله
تعسيس
بريد
الساعة
ما صار دبوي.
No, you
No,
need to.
Thursday.
You need some time to take.
هاي خميس صاحب.
You need
هاي
time.
وقت وأنا بهنا خميس ولا وقت وبهنا كدم بيصير ما دنا صبت اللي والله أنت.
سبت محل معنا تايد الله صدق معنا ما هيك.
Monday maybe, sir, or Sunday.
Monday, sir, or Sunday.
Yes, yes.
Monday or Sunday, right?
Yes, sir. Yes, sir.
So 10th of October. 10th of October. Is it okay?
Yes, sir. Yes, sir.
Yes, sir. Sunday, evening, sir, evening.
Sunday is 10th of October.
4 p.m., sir. Maybe 4 p.m.
4 p.m.
Yes, that's time, sir. That's good time.
Evening.
Evening, yeah. Evening.
Okay, I know. Just I give you the link in the messenger group, then you answer. That's it.
Okay. Evening, sir, evening, inshallah.
Okay, sir. Today you upload the videos. No problem. Lazizo.
Okay, I'm uploading because my Gmail is full. Because I have to upload all other videos in the previous semester. So I have to delete those things. Then I can upload yours. You understand?
Yes, sir. Okay, we are waiting today.
Okay. So now today I think I have to upload all. So okay, thank you.
Inshallah, sir.
You're welcome.
Sunday.